research methods. But first, a story. It's a story about Galileo. You all heard of Galileo?
Yes.
Galileo. He had a question which he wanted answering. And the question was, how do objects fall? How do they fall under gravity? Okay. Now, that question had been answered 2,000 years ago nearly by a guy called Aristotle. And Aristotle was the great scientist of his day, about 350 BC. He was the tutor of Alexander the Great, and he knew a thing or two about science. He's one of the big scientists of his day. And he said, it's very obvious how things fall. Things fall in this way. The heavy objects fall faster, and the lighter objects fall slower. That was Aristotle's view. And Aristotle was such a powerful and authoritative guy that everyone believed him for 2,000 years. And you know what? Nobody checked it. Nobody checked it for 2,000 years until a guy called Galileo came along and he said, well, it might be intuitive, but let's do the experiment. Let's actually carry it out and find out. I happened to live in a place called Pisa, which is in Italy, and he was Italian, and he was the foremost thinker of his day, and he decided he would take up to the Tower of Pisa. You know the Leaning Tower of Pisa? Yeah. Brilliant place. It's something like that at an angle. And the story is, some people say it's not true, some people say it is true, that he took with him two large balls of, what was a cannonball essentially, kind of thing, made of solid metal. And then the other one was made of wood. So one was a lot heavier than the other one. Okay? Took them over the Leaning Tower of Pisa. You stand on the edge. You're looking down. You can see straight the way down. You hold these two things. You let them go. So at the bottom, he's watching the measurement. What did he find? The heavy one? Did that hit the ground first? No, it didn't. It didn't. It didn't hit the ground first. In fact, they both hit the ground at the same time. And for the very first time, they did the experiment and found that it doesn't matter whether it's a light object or a heavy object, as long as the air doesn't cause a problem with it, you know. They look the same. They'll both hit the ground at exactly the same time. The experiment proved it. There was no doubt. Now, what have they done for 2,000 years? For 2,000 years, they've taken it on authority. By authority, a big figure, a big voice, big man, had said, fast ones go faster, heavy ones faster, light ones slower. And everyone believed them. Galileo, for the first time, said, I take nothing for granted. I question everything. I'm going to check it out. And that was really the start of scientific progress in at least the Western world here. That point where you do not take things for granted, where you're prepared to question everything, and you can then begin to discover real facts about the world, and facts which will change the world. Galileo changed the world. In fact, from him and his experiments, there came Isaac Newton and other people too, and a brand new law of gravitation was developed. And then after that, people questioned that, and they found that in certain circumstances that didn't hold. Another guy came along called Albert Einstein who questioned that theory, and that he found that when you tested that, that didn't work in certain circumstances. And a new theory was formed, Einstein's theory of general relativity. And that's improved our knowledge, and as years go by, we get closer and closer to a better picture of the universe, only because we question everything. You accept the words and authority of people, then you don't question things, and you don't make any progress. So, sorry? He didn't actually get put to death for heresy, but he was made to recant. And others were made to recant too. And he was made to recant because he believed the Copernican theory, which was that the sun was the centre of the solar system and that the Earth moved around it. And he was made to swear in front of the Holy Roman Church that the Earth was the centre and the Earth didn't move. And he actually, I'm told, he stood there and he, with his fingers crossed behind his back, he said, "The Earth doesn't move." And yet it does, he said under his breath, apparently. He didn't believe it. But anyway, that's another story. What I want to look at is what makes the difference then. What makes the difference between people who base their ideas on authority or what other people have said, and what makes the difference between those people and those who find out the truth about things. And I say the difference here is what we're going to look at today. It's based upon research methods. We're going to be looking at those techniques which really help you to get to the truth about how the world is, how your field that you're working in, the truths about that too. So I'm going to look at research methods, and one thing which I always do when I'm trying to understand something is, I don't know, one of the things I first bought when I was a student, about your age, was a dictionary. And this is just not an ordinary kind of dictionary, it's called an etymological dictionary. And an etymological dictionary is the kind of dictionary which gives you the root meaning of words. It tells you where the words actually come from. And I found that by finding the root meaning of words, I really began to understand what words really meant. I often found that I could use words in a way which, because I was familiar with them, I could use them, but I didn't really understand them. Only when you go back to the root meaning of words do you really understand the meaning of them. So research, when you look it up, that's made out of two parts. Talk about research methods. Research, read, and search. Searching is to look for something intensively, to try to discover something by examination. And read means again and again and again. To record, re-record, those kind of things. So it's looking again, examining again, looking at things over and over again to search things out. That's the root meaning of the word research. And method, that comes from two words, meta and hodos. These are Greek words. Meta meaning after, hodos meaning a travelling way. So it's going along a certain way of travelling is a method. Method is taking certain steps, therefore. And if you are following a method, you're following particular steps. So research methods are quite literally a re-examination, a close examination of things using a systematic and step-by-step set of methods. And that's what we're going to be looking at. Now, the nature of research is very special learning. It's a kind of learning which is different from all the other kinds of learning that you've done. And the reason why it's different is because whereas with learning, you're gaining information from what other people have taught you, research is where you're gaining information for stuff that you have taught yourself. Okay. It's self-generated. You need to have that internal energy which will take you to learning itself. And that's why you're at this level now. You're master's level students. And therefore you're people who have generated, you've been through lots of learning. You've done a whole bunch, you sat in classrooms like this and people have taught you all kinds of stuff. Here now, this is where we spring off, and it's time for you to learn things for yourself and the tools and techniques for learning for yourself, which is what this is all about. Okay, so research is about gaining knowledge, like learning is, but the difference with research is it's all about new knowledge, gaining of new stuff. And there's two kinds of research, which I want to point out to you that you're well aware of. Number one is what's called primary research, and the other one is called secondary research. I've got it down here. Primary research is where the people who do the work of the research are gaining brand new knowledge which no one knows. That's a really fundamental, powerful kind of stuff. I'm not expecting you to do that here. PhD students have to do primary research, they have to gain new knowledge. If you go on to do a PhD, you'll be required to do some original work which other people haven't done, gain some new knowledge and push the boundaries of your field back a bit further, a little bit area. New knowledge that no one knows about before. But there's also this other kind called secondary research. And secondary research is where you gain new knowledge, but it's new knowledge to you, not necessarily new knowledge from the world. It's knowledge which other people have already found out, written about in papers, and you draw it all together, and you study it, and you catalogue it, and you learn from that. That secondary research is looking at work that other people have done and bringing that into scope. So here's a brief table of it. You have your primary research here, you have your secondary research there. Primary research is essentially done by you. If you're doing primary research, you will work through it and you create the knowledge, whereas secondary research, you're looking at the work of somebody else. Primary research, new to everybody. Secondary research, new to you. Types of primary research, people use methods to do that with: surveys, groups, focus groups, interviews, experiments, observations, that kind of thing. But for secondary research, it's just usually a literature review. You're looking through other people's papers, books, those kind of things. And there are advantages and disadvantages to primary research. The advantages are it's a novel information, cutting edge, high costs, takes longer. And secondary research, the most important thing about it is this. This is the kind of research you'll mostly be doing here, is secondary research. And the importance of it for you is very simply stated. With secondary research, what it does for you is very, very important, because it makes you an expert in your chosen field. Without it, you're a complete amateur. You don't know what you're talking about. You haven't done the background work. But with true secondary research, you become an expert in your area. And you cannot do without that bit. And you won't all be doing the same thing, you'll be doing different things. But you'll become experts in the area in which you're working in. Only if you do the secondary research.
Surely you have, well, you can, primary research, you have to do secondary research before you can do primary research.
Then if you can, oh, not on this slide, on the next slide, I think. Yes, exactly. Normally it's a good starting point. The secondary research is your starting point, the springboard to go on. And only when you become an expert can you really begin to do the primary research. But just to be quite clear to you, I'm not expecting anybody in this unit to engage in primary research. At the moment, we're engaged in secondary research, which is the first level of research. Okay? So don't worry about that. Primary research has to be original, new stuff, things people have never invented before, maybe even discovered before. With secondary research, you have to catalogue what other people have done and bring yourself up to their level. That's where we're at here. Okay. Just want to clarify the difference between the word methods and methodology, because there's a difference between those two things. Methodology, I've got on the slide, is the study of methods and deals with the underlying research process. In other words, it's how you plan to do your research in the overall general scheme. Whereas a method is a particular scientific technique for collecting data, usually. So that might be, how to develop certain tests, how to calculate various statistical inferences. These are all techniques. These are methods which you might use. And we'll be looking at the kind of methods which might be involved. We'll be looking at statistical methods, data analysis methods. Later on, we're looking at literature review approaches, how to do that. And those particular methods are what this unit's about. Research methods. So we will be looking briefly at research methodologies, which is like the overall scheme of how all the methods fit together, how to choose the right methods, what are the best methods for this approach or that approach. So, methods that we might be looking at then, I've classified them into two parts. We've got this bit here is primary research methods, and this bit here are secondary research methods. Now, the secondary research method is essentially the literature review, which means looking up other people's papers, journals, conference proceedings, books, even magazines and newspapers, and it can be a quantitative or a qualitative method. I'll explain those in a minute. And that's usually the starting point, as we mentioned earlier on. You might move into some of these things if you wish to do that as part of your project. But for this unit, you'll just be doing essentially the literature review. So that's where we sit in this unit. And then for your project, you might go on and you might want to do a survey for your project, or you might want to do an interview. You may even want to do observations or even some kind of experiments. That's up to you. That's what the nature of your project's about. But they will take you into primary research areas to a little bit, to a small extent.
Since the purpose of secondary research is primarily personal development, is there recognised benefit?
So these are ways of adopting these methods and how they're applicable. And over above everything, there's the difference between deductive and inductive strategies. Inductive is about going from the particular to the general, getting general rules out of particular observations, and deductive is about going from the general to the particular, the opposite way.
Does any research can inductive and deductive being used in the same research? Is it
Can what be sorry?
can I say that I'm using a research strategy of inductive deductive? Is it both?
Yes, of course you can. Yes, it depends on what you're trying to do. If you're trying to establish a particular theory and create a new theory, you might do a lot of series of individual observations and then, by the process of induction, produce a general rule which applies to all of them. And that's induction. Whereas deduction is looking at the general case and then seeing how that applies in a particular instance and making sure that checking that that's so. Right. So, I'm going to trace back the start of the scientific method, if you like, to Galileo. Some people might trace it back to other things, but Galileo was really the starting point for me, anyway. My background is that of being a physicist. My training is in physics. I did work originally in a field of physics called quantum mechanics. So I'm more versed in that. And I look back and I see that really a big milestone in science, at any rate, was Galileo and the way in which he used experiments and the scientific method to check things. And you know what, I feel that is probably one of the most important parts of what this is about, because our research methods, when you trace them back, they are traceable back to what's called the scientific method. I just want to say a word or two about the scientific method and then show you how that really is the root of what we're doing. Because when you ask yourself the question, what is it that distinguishes science from non-science? I mean, there are lots of things that you find in this world that people look at and think, that must be true, that's true, or they take for granted that they're true. Things like reading every daily newspaper that's got horoscopes in it. A lot of people believe them to be true. But are they true? And are they scientific? A lot of people believe in astrology, or they believe in crop circles, or there's debatable areas about homeopathy, or there's the stuff about acupuncture, Chinese medicine. All these different kind of things. Are they science or are they not science? What makes something scientific? What makes something not scientific? What is dependable and what is not dependable? What is true and what is just hearsay? What is an old wives' tale, as we say, or what is established as something you can rely on? How do you distinguish between those things? And the mark of distinction, which marks them out, is that between that which is scientific and that which is not, and that which is based upon the scientific method and that which is not based upon the scientific method. You know, if you look back in history, in this Western world anyway, we had what was called the Dark Ages. The Dark Ages were the time when people didn't really understand anything and there was very little progress. And what happened was, right up until about 1500, 1600, that kind of time, people didn't think very clearly and there was no scientific method. People believed the most astonishing things which were just not true. There was no scientific progress in medicine, there was no scientific progress in many, many fields. But certainly what happened at a time when you have what we call in, say, Western culture, the Enlightenment, a big change took place. And the big change was simply this, that from that point on, before the Enlightenment, you couldn't question anything. You had to accept it as true. If the church said so, or if the state said so, or whatever it is, you just had to believe it. And no progress was made, and no improvements were put in place. From the time of the Enlightenment onwards, about 1600, 1700 or so, everything was questionable. You could check everything, you could test everything, you could demand that someone proved something. The whole mindset shifted. And from that point on, people began to say, I'm not accepting this unless you can verify it's true. I don't accept it because so-and-so said so, or that person said so, or the great man of the past who said so. That's not good enough. What I want to know is, what is the evidence for that? What is the evidence for that? I've got a couple of kids, and when I brought them up, I always used to teach them to say, what is the evidence for that? If I'd say something, what is the evidence for that? And they would challenge all kinds of things. In the end, they're sort of challenging me, saying, why have we got to go to bed now, Dad? What's the evidence for that? You know. But that was good. Inquiring mind, what is the evidence for things? And to begin asking those questions, to have a rational point, is important. How do we know that something is true? We do not simply accept the words of clever people. We have to be convinced in our own minds. And that is what Galileo did. He had to be convinced in his own mind. And he went up that tower with those two balls in order to check that these things were true. He found that they weren't. And you know what? Most progress is found out by people who find that something doesn't actually fit the way in which everyone said it did. When you find things that don't fit, that's the time when revolutions occur. And the moment that we stop checking things for ourselves, the moment that you stop checking stuff, that's the moment that you enter into your own dark age. That's the time when you will begin to not understand things and accept stuff that everyone tells you. Sorry.
Maybe I'm thinking sometimes we are trying to live in a second dark period because people trying to believe whatever the media says. We accept whatever media says. Most of the people. Maybe it's the start of a second dark period.
That's what I was going to say, because history teaches us that everything is cyclic. So, in some ways, we might have come out of it at one point, but we are going back to it again.
Yep. Yep. I mean, what you say over here is very astute, and the media do control the mindset of people. But, and this is the important thing for us in this room today, we will not let that dictate our agenda or our thoughts, because we will check things for ourselves. And we will not accept things just because the media tell us it's true. I don't know about you, but I've occasionally, you see things on the newspaper and you read the story and you think, is that really true or not? Occasionally I have been sort of privy to knowledge of what has happened behind a true story, and I know what's really happened, and I see it in the newspaper. And on the 2 occasions when I found that to be the case, almost every single fact in the paper was wrong. The little facts, all wrong, totally wrong. And I think to myself, if that's true of the 2 stories I know about, how can it not be true also of all the other stories I read?
Sorry for the interruption, but also the same people who control media control the education systems.
Why do media people want to control newspapers? Why do they want to control television stations?
No, also,
and why do the politicians want to have them on board and do it?
it's an endless cycle. I don't know. It's a loop. Endless loop.
The media likes to scare on people, and it's kind of the way that it sells the newspapers. And it's one of the primary reasons that they have bad statistics is because it goes, oh look, dangerous place, don't go there, and then people don't go.
But the lesson for us today is that we're aware of that, and most people are not aware of that. Unfortunately, that seems to be the case. But I think thinking people who are determined to think for themselves, will not be taken in by those kind of things. And the way not to be taken in is you simply require evidence of the things before you accept them. Where is the evidence of that kind of thing? And if you haven't got the evidence yet, you say, I'll suspend judgment until I get it. So the scientific method is the way in which you approach things and get things clear. Now, I've got, if you look at what the scientific method is, I just want to explain to you. I've got a simple five-step understanding of what the scientific method is really all about. This, for me, distinguishes the difference between science and non-science. Science and nonsense. Okay. That's what it is. And here it is. The scientific method is a process. It's a very simple process, and it's a process first put together, I say, only some hundreds of years ago. It wasn't a scientific process before that time. But here's the process. Someone asks a question. How do objects fall? They construct a hypothesis. What does that mean by that? The hypothesis, let's guess how they fall. And the guess is, heavy objects fall faster than lighter objects, which fall slower. That's my hypothesis. Right, got the hypothesis? Good. Test it with experiments. Up until the end of the Dark Ages, people stopped here. That's as far as it went. It didn't go any further. And when people said, well, that sounds reasonable, heavy objects fall faster than, yeah, that sounds reasonable. That's the answer. That's how gravity works. Not so. Not so. No. And Galileo took it to the next stage here, tested with experiments. So, went up to the tower, dropped the thing, found it wasn't true. Analysed the results. The results were heavy objects do not fall faster than lighter objects. Therefore, formulate a conclusion. Hypothesis, wrong. Give us another one. In fact, what you find is that all objects fall at exactly the same rate. All of them. Light objects, heavy objects, they all fall and hit the ground at exactly the same speed. You might say, wait a minute, I know that if you drop a feather will go like that. Yeah, but that's air resistance. In a vacuum, it will fall exactly the same as a cannonball.
That sounds really big enough to show it.
I'm sure they can do those experiments now.
There is a video on YouTube done in a NASA vacuum chamber. There's a guy doing the experiment with the feather and the ball.
But the important bit here is that it's done with this important section. Test it out for yourself. Ask the question, construct the hypothesis, test the experiment, analyse the results, formulate the conclusion. That is the scientific method. And the key step is that one. Check it against real experiments. Does it really happen? Check the evidence for things. Is the evidence there? Now that is the root of our research method. That's the point I wanted to make here. The 7 characteristics of a scientific research is, I've got 7 points here very quickly. Scientific research is therefore empirical. You may come across this term empirical. All it means is it's based on evidence, on the facts. Yeah.
The diagram you put up, where does scientific, measurable, observable facts and replication lie in the diagram?
It's a simplified form, and replication would have an arrow going back up to the top, so that you can repeat things. And I think that everything. This is my next stage here. Where we are. Number 4. Scientific research is replicable, repeatable. Yeah? And it has to be so if you've done it properly. Scientific research is empirical. It's based on evidence. It's based on concrete data. It's means it's checkable by experiment or fact. It's logical. It's guided by rules of logic. It's systematic. To go through these steps here, I'm just going to touch on them lightly and give you some idea of the steps that you will be required to take during this unit, so that you understand them. So, number 1, formulating the research problem. Research method. I'm not about that because it's nicer. Formulate the research problem. That's our first step on the journey here. And I often say to students, you do not really understand what your project is about or what your work is about unless you can form yourself a research problem. The problem is the important bit here. Now, let me try and make something a bit clearer to you. In the past, you've done projects. You've done projects at undergraduate level. And those projects could have been very practical. Practical kinds of things. For example, it might have been create a website for a customer. Okay? That's fairly easy to do. And that's the kind of project you did. But what's required at this level is something a bit different. Something more demanding from an intellectual point of view. It's not good enough to say, I'm going to use my skills as a programmer and create a database. That's not the issue here at this level. The issue here at this level is, what is the problem that you're going to solve in doing the project? What is the problem? It has to be an intellectual problem. What are the techniques you're going to be using? What critical skills are you going to bring to bear on this? And just creating a website is not good enough. Not good enough at your level. You need to be saying to yourself, and then you have to use your critical faculties to start saying, right, what are the issues involved in this particular group of people? What are the items which I've got to grapple with? What are the problems here that I've got to be able to elucidate and work through? And by design something that looks like it's suitable. As it happened, the Blu-ray wins out over the other one. There were 2 competing schemes, but how do you find out what's going to happen in the future? It's not really a research problem that you can solve. It has to be a solvable problem. It has to be something which, by doing something, you will get a definite answer to. So, formulate your research problem, and then number 2, engage in the literature review. Now, I'm going to spend a whole session on how to create a literature review. I'm going to take you through the steps, because you're going to create a literature review for yourself and as part of your work. So I'm not going to go through all of those steps now. I'm going to tell you that essentially you will need to do this. This is indispensable for you. It's something which is valuable to you. It's something which will make a big difference to you. It's something which is important to you. It's something which will change you. It's something which will make you an expert. It will make you an expert in a field. It will make you rise up to the level of all those people who are writing papers on this subject. That's what the literature review does. And that's why you cannot do without it. And that's why it's important. Okay. So, we will see that. So once you've got your question, your problem, you have to go away and do your background reading to come up to the level of a stage whereby you can start to do something about it. So that's that one. The next one is develop your hypothesis. The equivalent of Galileo saying, I think they're going to fall at the same rate. I'm going to go and test them out. Well, you can have a hypothesis for your project as well. Whatever it is you're going to be working on, you have a kind of educated guess as to where things are going to go. And you could be working to be able to test that. That's the point of it. Can you test what you're doing? So you have a working hypothesis. You need a hypothesis because the scientific approach insists that you're testing something. You're using experiments or surveys or interviews or focus groups to test something out. So what are you testing? You're testing the hypothesis, the idea that you've got. And that's a conjecture which relates two or more things together. You know, my hypothesis is that people over the age of 17 do not use mobile phones. Well, you can go away and test that, can't you? Because you can set up an experiment or a survey to do that. But whatever your hypothesis is, it must meet this criteria. It must be testable. And your work will be involved in testing whatever your hypothesis is. That brings us to this one. Prepare the research design and the sample size. And there's quite a lot involved in that. I don't want to go through this in too much detail at the moment, just to give you a flavour of it. But when you're preparing the research design, you're asking yourself the question, what steps am I going to be taking? What are the steps I'm going to be using here to do that? How am I going to gather the information? What methods am I going to use? What tools and resources do I need? What sampling is going to be done? If I'm going to make a statement about the population at large, I can't talk to all of them. I've got to do some sampling. That means taking a number of them. How will I do that? How are the data to be organised and analysed? How will the validity of the data be checked and addressed? Oh, anyone like Dilbert? I'm a great Dilbert fan. Dilbert is a guy who sits in a cubicle and he has a pointy-haired boss. That's him, who doesn't know anything. And he has Goldberg, who's the consultant. He doesn't look like a consultant, but he is. How does he determine his sample design? He's hired at huge expense. This is the Dogberg Research Company. Have you ever been killed by a poorly designed product? No? My tainted research shows that your products haven't killed anybody. For an extra $50,000, I can call a second person. Very poor sampling, one would say. I don't want to jinx it, says the boss. Not unsurprisingly. But sampling is an important factor. And maybe to you, if you've got a large group of people to look at it, and maybe you want to look at all students or whatever, how do you determine your sample size? There are lots of ways of choosing groups of people from within a large group. And I've got just the name of some of the techniques: deliberate sampling, simple random sampling, systematic sampling, stratified sampling, quota sampling, cluster sampling, multi-stage sampling, and sequential sampling. There's lots of ways of doing it. And you need to be able to know what the techniques are. You need to be able to know which is the right technique in your circumstance. How do you choose between them? We look at those later on. Determining the sample size. Sampling methods in a diagramatic form. I just chose different ways of doing it. Moving on, collecting the data. That's nearly there. There's lots of ways of collecting data. I've got a list of them there. There's primary data, secondary data. You can do it by observation, interviews, telephone interviews, a range of different things. But your data has to be properly worked through, and the methods for collecting have to be carefully understood. Just producing a questionnaire, for example, is a complicated operation. I'll explain why that is. So often people ask questions which they don't even use the data for. Data can be of two kinds. You need to be aware of quantitative data and qualitative data. Two different things. Quantitative data is all to do about quantity and is to do about numbers, therefore. Numbers come out of the data, quantity, amount. Qualitative data is to do with quality, and it's often to do with words. So quantitative research based on quantity or amount, often gone through with statistical tools to check the quantitative analysis here. Qualitative data, you might get that by interviewing people, asking them questions, or and just getting their views on things. Subjective assessment of attitudes and opinions, focus groups give qualitative data. So what kind of data are you about? And can you check that it's okay, that it's valid? Analyse the data. There are many means of analysing data. It depends on what kind of data, whether you've got qualitative or quantitative data. There are different tools for that. Analysis. You know, my etymological dictionary always comes in handy when I'm looking at words. I used to be able to use words like analysis, and I didn't really know what they meant. I'd use them because I was familiar with them. I'd be familiar with the word analysis, and I would drop it into my conversation, and I thought I understood it. But I never properly understood the word analysis until I got my etymological dictionary. When I got my etymological dictionary, I looked it up, and the etymological dictionary told me, did you know that the word analysis comes from two Greek words? The first Greek word, ana, and the second Greek word, lusis. Let's see what the ladies mean. Lusis actually means to tie something up. So if you tie your shoes up, that's the Greek word for lusis, is to tie up. Take a bundle of sticks, put a cord around them, tie them up. That's what the word lusis is about. Ana is the word which you put in front of another word in Greek to mean the opposite. Like we use the word anti-clockwise, for example. Anti means clockwise goes one way, anti-clockwise means you go the opposite way. Moral, and then you've got amoral or unmoral, immoral. It's a little word you put in front to mean the opposite. So analusis means to untie things. And when you untie things, it means you take the bundle of sticks that are tied up and you undo it and you lay it all out, and all the sticks are all separate and in their parts and in their components. So an analysis is quite strict and literally a breakdown into component parts. That's what an analysis is about. You're breaking things down into components. If you had a bicycle and you had a spanner, then you could use that spanner to analyse your bicycle. You analyse your bicycle by undoing all the nuts and bolts, laying it all out in component parts, and there you have analysed it, because it's now in components. That's what the word analysis means. I never knew that until I got my etymological dictionary. And here we are. Analysis means breakdown. Analysis of data requires, usually you use categories to break down things into different categories or classify them. And you can use coding and tabulation and tables, and you analyse things in that kind of way. So it's all broken down into components. You will need to analyse your data. You'll need to set up classifications, you'll need to put them into classifiers or like pigeonholes, and you analyse it this way or analyse it that way. That's what we will do in our research methods. After that, we test the hypothesis, because having analysed the data, you can then find out what really happens. Did the facts support the hypothesis? Did the balls hit the ground at exactly the same time or at different times? What did the facts say? And you can use different ways of testing the hypothesis. I mean, the analysis can involve chi-squared testing, t-testing, f-testing, all kinds of statistical tests you can use. Fine, everyone will help you. But the hypothesis testing would result in one of two events. Either the hypothesis is accepted or the hypothesis is rejected, and then you've got some real knowledge, then you've got some real understanding. Come to the final stage, we have interpretation, and what does it all mean? And you will need to write up your interpretation in a kind of dissertation. For your project, you will. You'll have a big, thick dissertation of, I think is it 15,000 words? Something like that? It's a lot. What to do. But for me, in my unit here, the research method unit, you'll just be doing the literature review kind of part of it. And that will be resulting in a paper which you'll write of about 3,000 words. Not that demanding, but at the starting point for your project. And that's where the interpretations will come out, and you'll explain them all in there. So there we have it. And that's my final slide. Research methods. I've given you an overview of the entire process. Is it what you thought it was? Because now is the time to say this unit's not for me, off I go. That's what's in store for us. That's the process we're going through. That's what we're about. Okay? We're all with that. Thank you. Right. Let's take a
But
five.
again, sorry,
Sorry?
this hypothesis can only have two outcomes: accept and reject.
Yes, I think hypothesis. Yes. Why? This is the third one you can think of?
Yeah.
I can't think of any. No.
I
Either the
just
hypothesis work, either.
Can stay open.
Sorry?
Can stay open.
They can stay open if you're undecided. Yeah, but then you do it again. You do an experiment. And in the end, the hope is to get one or the other. Okay. Oh, good point. Good point. Thank you. All right. We'll have a 5 or 10 minute break.